Okay, here we go, Math 10. This is 6.5, difference of squares. And if you remember from our factoring rules, that is this part number 2. Does it have two terms? Is it a difference of squares? That's this one. Okay, so we're going to start with ones that look like this, x squared minus 16. So there's two terms. They are both something that is squared, and they are a difference. It has to look like that. When it does, the form is square root this part and square root the second part. Those go in brackets, and one is negative, one is positive inside the brackets. So that's what you're going to memorize. These are the easiest to do, they're the easiest to forget. Here's why this works. If we had x squared plus 0x minus 25, we've done these, but we've never had 0 in there. That's weird. But oh well, we'll just not worry about it and pretend we don't realize that that's weird. X and x, how about 5 and 5? Plus and minus, oh, I'm going to get minus 5x squared plus 5x squared is 0x squared. Hooray! So then my factors are x plus 5 and x minus 5. Once we realize that process, then we don't have to do this anymore. We don't have to make a 0x, but if we forget, we always could put in a 0x and just make it easy for ourselves. So if you look at example B part above, try these two. So pause and try the x squared minus 9 and the second x squared minus 49. Okay, so we should have square root of x squared is x, square root of 9 is 3. So x minus 3 and x plus 3. The end. Here, square root x minus square root is 7 and x plus 7. So these are going to become really fast for you. So x minus 6, x plus 6. Unfortunately, these are all on the same page, and when you get to other ones that have them mixed up, sometimes you get to these and forget because they are so easy. Let's do one where they have, I don't know. Well, let's see what they have for this guy. Okay, so let's do 4t minus 7 and 4t plus 7. Pause the video. You keep going. 1, 2, 3, 4, 5 of those. And then play and watch my solution. Okay, so here's what I am hoping you are thinking. 9a minus 1, 9a plus 1. C part, 10 minus y, 10 plus y. D part, 6p minus 5, q. Woo, almost missed that q. And 6p plus 5q. E, 2, oh, I almost got trapped. Look, there's a plus. It's not a difference of squares. There's nothing we can do. There's no great rules for plus of squares, just difference of squares. If we did 2x and 2x and 5 and 5, plus and plus, we're going to end up with 20x in the middle. We could do minus and minus and end up with negative 20x. We could do 25 and 1, but it's not going to work out. So can't factor. And this one, 8 minus 3ab and 8 plus 3ab. Yay! So formula-wise, it's always going to look something like a squared minus b squared. And then your factors will be a minus b and a plus b. Okay, let's see if these look any harder. Factor the following polynomials by first removing the greatest common factor. Okay, go ahead, pause, and then turn back on the video. Here we go. So 2, I'm going to have a squared minus 25. And then I realize this is a difference of squares, so 2a minus 5 and a plus 5. Here I can take out a 3, so let's factor out that 3x squared minus 4y squared, and 3, then x minus 2y, x plus 2y. C part. I can factor out a 4, but what if I didn't realize that? What if I just went along my merry way and went, oh, well, that would be 12pq minus 2 and 12pq plus 2. That's fine because here I would realize, oh, I can factor a 2 out of this first term. I can also factor a 2 out of the last term. 2 times 2 would be a 4 out front, and I'm dividing this by 2, so 6pq minus 1, and here I'm dividing by 2, 6pq plus 1. So it doesn't matter when we factor it out, as long as we're looking for more factoring in the terms as soon as we think we're finished. Here, let's take out a 3 and an x, and I've got x squared minus 9 left, and then I'm so happy. 3x and x minus 3, x plus 3. Okay, these are so great. Questions 4, 6, and 12 to 14. You will love them, and I hope you remember them when we put them all together with other things. See you later.